informed and consent domain. That's very, very important area. Informed consent model for brain operation of aneurysm is very, very important because in operation situation, patient is completely okay. Inside the brain, there exists some trouble, but it haven't realized now, not ruptured. But in that situation, so surgery doctor decide to operate, and also patient have to decide he will be operated or not. So informed consent is very, very important. Compare option and immediate surgery operation with the delay of the operation. This is very, very serious because it's my brain. So it's a decision of mine. 5 millimeter aneurysm has found. And wait until 10 millimeter, then operation or immediate. That's the problem for me. So I simulated that one with the collaboration of doctor. In this case, starting and age and any. And this is a natural death in the ruptured case and complication by operation case. Okay. Now 100 person of me, copy of me in natural death and rupture and complication. And in my decision, I have taken immediate operation, and now I'm here. That's okay. And anyway, so that kind of simulation is very, very useful for informed consent. Informed consent is to construct a shared internal model and decision. Okay. This is a 3 millimeter aneurysm has found and wait until 5 millimeter. That is a very, very feasible decision. Okay, anyway. So it is important to understand what is the best option of surgery operation, not only from the informed consent point of view, but also from the health insurance point of view. It's very, very important. Okay. And another one is the tragedy of commons, hybrid gaming cases. And this is a rather theoretical one. You know the concept of tragedy of commons. It is very, very famous in social sciences. So you live in a village, you raise sheep in a village. All people in a village have sheep, but place for raise sheep is limited. All people can raise sheep only in commons. So in this situation, we can easily construct a simulation model. But the simulation model is a simulation model. If we can attain the situation as a player, then we can understand directly from simulation. So a kind of participatory approach in the simulation world. Anne, Alice, Bob, Cassie, Amy, Betty, David. And in these people, 4 people is a machine, and 3 is a real person. And anyway, so in this tragedy of commons, situation is a bit different from standard one. So people have to invest for increasing the sheep. So borrow the sheep and increase and return the sheep. Then, winner take all mechanism will happen in standard this kind of one. So in standard model, there happen king of poors and bankrupted people, so many. But in this case, we can add some policy on this society. For example, subsidy or tax. So tax for king of poors, then how this world changed on simulation. Okay, in that case, king of poors and maybe second king will happen. But so many people bankrupted. But if we add, tax and subsidy for bankrupted people, then competition becomes drastic. So our society might change the competition situation under the boundary political condition. That example shows that kind of the importance of political boundary condition for our competition. Some people think, well, winner takes all. Okay, that king might have enough talent, but situation is like this. So boundary condition determine this social structure. Who become a king of poor? I don't know. But of course, maybe some talent might affect. But the most important thing is the structure itself. Social simulation give us that kind of insight. That's a very, very important point. And also another big model, simulation-based epidemiology and simulated tabletop exercise. Actually, we have smallpox bioterrorism simulation. This is a very, very complex one. But agent-based simulated epidemiology is a very, very important and now emerging domain. So today, I'd like to give this example, and also for discussing the methodology of agent-based modeling, I'd like to use this example. So for constructing the model, city structure model, and population structure model, and human activity model in the city is required. And this is our simulated graph. Red means the infected person, and this means the non-infected, and this means the hospitalization people, and black means the dead people. And yellow means the number of vaccinated people. So anti-pandemic agent-based social simulation model supports typical type of interdisciplinary research. Actually, well, this is a pathological transition model, and city structure model, and human activity model, and infection process model itself. And it's too complex, and it's not a medical domain research, but a typical type of interdisciplinary research. Yeah. Okay, I'll show in detail later. Okay. This is a pathological transition model. That means a non-infected person and infected and serious line and die, or moderate and recovered and go back to society with immunity. And this is a city structure model, home and what kind of school and office and so on. And well, this is the activity model, how people acting on the society. And this is this is a bit difficult. But this is the infection process model. We call this as a filter model. I'll show.
So each of these is a modeling effort in its own right, and then you're going to show how we can integrate it.
Of course, integration is essential, and methodologically integration is essential. So first, pathological model, disease stage model under the physical condition and medical treatment. This is a basic model, and only this part belongs to medical domain. Okay. Anyway, so pathological transition general model. So no excretion, high fever, and moderate cases. This is a probability, transition probability. And day 1, day 2, and so. And this is a pathological transition model for smallpox. Okay, infected 14 days up to high fevers, serious case, or moderated but very, very dangerous for other people cases. And this is the recovery route and critical condition and death route. Okay, so. And this is a pathological transition model for a new type of influenza, swine flu cases. Okay. And of course, this is a very, very simple one. If in the case of swine flu, we take a treatment like so Tamiflu, then transition probability will change like this. So this is a typical medical domain knowledge we required. And this is the infection process model. It's a bit different from standard medical domain's knowledge. Okay. In these cases, we constructed a filter model. So that means, well, actually, there are so many missing links on epidemiology. Evidence on epidemiology usually means not for microdynamics, but for static and statistical event. In many cases, social science and some part of medical science consist of that kind of static knowledge. So microdynamic knowledge is actually required, but it's very difficult to develop. So social simulation helps that kind of domain. And mathematical model of infection, like a SRI model. This is a very, very famous model in the infection process. But this is a typical type of macro model. And percolation model is a simple and micro model, but not suitable for a realistic situation. So we introduce some assumption. Person who have contaminated go to some special places like here. Then contamination of the place, we say spot, will happen. And if contamination spot exists and no contaminated person here, then contamination of the body might be happen. And so this is this process, and this is contamination process. And well, and this is a serialization process. So contaminated place and not contaminated. And contaminated person, non-contaminated. And contaminated person to what? Infection. This is the last part. So this symbol, this symbol we say filter. So for example, mask become a filter for place contamination, against place contamination. And in these cases, N95 mask or space density itself become a filter against contamination. And in this last process, vaccination become a filter. So there are so many filters depending on the situation policy and also depending on the organization or place. So total combination of that kind of filter against contamination or infection determine the infection process, macro infection process. So combination of weak filter might construct a strong filter against infection risk. And the city structure model. Actually, in these cases, we constructed a very, very small model, 10,000 population city. And elementary school 3, high school 3, and then so on. And also demographic structure of this generic city. So this is the total population is 10,000, but the ratio of family, so family structures ratio have to be determined, and also age blanket structure must be determined. Then human activity model should be added. So depending on what kind of schedule each age of people are working or moving in this city. So model of virus contamination and infection process is described totally. So infected person and filter and spot, it might be contaminated, and this is a sterilization process. And this is a person who are contaminated, and this is a filter and sterilization process, and last part is the infection process, and this filter means, well, vaccination.